Let's talk about note card 56, solving exponential equations using logarithms, and we're also going to review other logarithms at the end of note card 56. We're going to review expanding and condensing and evaluating logarithms, and even solving some other types of equations with logarithms. Okay, so what I'm going to do in talking about note card 56, I'm just going to work some examples, and these examples are going to come from the homework that I assigned you. And let's just start with something like number 3 from the homework assignment. So you have e to the power of 3x is equal to 15. And so what we want to do is we want to take log base 10 of each side. Now that we've done that, we want to utilize the power rule, which says that this power inside the logarithm can come to the front and become the coefficient.
Teachers, please pardon this interruption. At this time, all members of the varsity choir need to report to the choir room. Again, all members of the varsity choir, please report to the choir room at this time. Thank you.
They should already know that. Okay, now I've got 3 being multiplied with x, being multiplied with log e, and I want to get x by itself, so I'm going to divide by 3 log e all at one time on each side, which causes these two things to cancel, and what I'm left with is x is equal to log 15 divided by 3 log e. This is your simplified answer in terms of logarithms. Now, if I asked you for the decimal equivalent on an exam or a quiz, you would know that you would need to put this in your calculator, making sure you utilize parentheses, putting the entire bottom in its own set of parentheses, and then hit enter, and that'll give you the answer in decimal form, the decimal equivalent. Let's work one a little bit more difficult with variables on each side. This is number 9 from the homework assignment. First thing we want to do is we want to, again, take log base 10 of each side. The next thing we want to do is utilize that power rule where the powers that are inside of the logarithms can come to the front and become the coefficient of the logarithm. Now here's where it gets a little bit different than the other one, because of the fact that we have variables on both sides of the equal sign. I have an x on the right side of the equal sign, I have an x on the left side of the equal sign. So what I'm going to have to do is I'm going to distribute this log 6 into this x minus 2. You have to remember that this is just a number. It's just a constant. This is just a number. It's just a constant. If I were to plug log base 10 of 10 inside the calculator and hit enter, it's just going to give me a number. Okay? So it's just a constant, but we're going to leave it in terms of the logarithm for now. So I'm going to distribute. So x times log 6 is x log 6 minus 2 times log 6 is 2 log 6. Bring the other side down. Now what I have is I have still x's on the left and I still have x's on the right, but now they're separated. I'm going to take the term with the x's in it to the left side. Now it's positive, so I'm going to subtract x log 6 from each side. This cancels. x log 10 minus x log 6, and I just rewrite it because they're not the same things, and so I just have on this side equals negative 2 log 6. And now what I have is I have two terms on the left side of the equal sign that have an x inside it. So I'm going to factor that x out because that's the GCF. Just pull that out. And so when I divide or factor out an x out of both of these, what I have left is log 10 minus log 6 equals negative 2 log 6. Now I'm solving for x, and x is being multiplied by this difference here, the log 10 minus log 6. So I'm going to divide by that. That cancels. And I get that my answer is x equals all of this right here. The negative 2 log 6 divided by log 10 minus log 6. Now again, if you were going to give, this is the exact answer. If you were going to give the decimal equivalent, you would make sure you would use parentheses. You would need to put all of this in the appropriate parentheses. Now, when you hit log in the calculator, it opens this parenthesis up. So you just close it off. Then on the bottom, you put the whole thing in its own set of parentheses as well. And if you use your parentheses right, that would give you the decimal approximation. Okay, moving on. That's summed up note card 56. Now let's just go back to logarithms number 1 and let's just work through some examples. On part 1, okay, this is part 1 of logs 1, and we're going to do, let's just look at a few of them. Here's f. Log base 3 of 9, and it wants to evaluate this without a calculator. To me, the easiest way to do it is set it equal to x, and then they all work this way. 3 to the power of x equals 9. Well, what power do I have to raise 3 to get 9? X equals 2. Okay? Number 2, not part 2, I'm sorry. Let's look at h. Log base 2 of 2 to the 10th is equal to what? Well, 2 to the what power is equal to 2 over 10. Surely you can see that x is 10 here. Let's look at j. Log base 2 of 1 over 8 is equal to what? Well, 2 to the power of what is equal to 1 over 8. Now the trick here is this. If you have a fraction with 1 on top, you're going to have a negative exponent. So just look at it this way. What power do you have to raise 2 to get 8? And hopefully you can say, well, 3. But since it's on bottom, it's going to be negative 3. So that's x equals negative 3. Because 2 to the third power gives you 8, but since it's a negative exponent, that 8 goes on bottom. Okay, and finally, let's look at L. We've got log base 6 of square root 6 is equal to what? So this is 6 to the power of what is equal to square root 6. Well, if you mind your P's and Q's, you remember that Q is 2 and P is 1 here. So that's going to be a fractional exponent. And so x is equal to 1/2 because P over Q. You have to remember all your P's and Q's and all that business. Let's move on to part 2. Part 2, let's look at B. Log base 10 of x minus 1 is equal to 3. And we're evaluating or solving for x without a calculator. Still works the same way. Remember, this is base 10, so 10 to the power of 3 is equal to x minus 1. So you just solve it now. Now you've come up with an equation that you would solve. 10 to the power of 3, 10 times 10 is 100, and 100 times 10 is 1,000. So that's 1,000 is equal to x minus 1, and x is equal to 1,001. Let's look at part F. ln x is equal to 0. You might want to recall, you may even want to rewrite the ln x as log base e of x is equal to 0. So now we have e to the power of 0 is equal to x. Well, anything to the power of 0 is 1. So with parts 1 and 2 so far, they all work the same way. You take the base, you raise it to the power of what's on the right side of the equal sign, and you set it equal to what's inside the logarithm itself. And between the parts 1 and 2 that we're looking at, you're solving for x somewhere. And that's how those work. Part 3, quickly, it says use the calculator to solve for x. Let's look at part B, or no, yeah, part B of number 3. It says ln x is equal to 4.2. Well, again, let's change ln x to log base e. Log base e of x is equal to 4.2. And then e to the power of 4.2 is equal to x. And the reason why you have to use a calculator here is because your exponent or your power here is a decimal. You just plug that in your calculator and you got it. Let's look at part 4. We're going to convert to a logarithmic expression. So if I have part B, e to the x is equal to 5. Here's what you have to remember, and you should have this in your note card notebook somewhere. When you're talking about an exponential function, you have a base raised to a power, and that's equal to what I call the argument. And to convert this to a logarithm, it looks like this. Log base of the argument is equal to the power. So using this information, you should see that the base is e. So I have log base e. The argument is 5 is equal to the power, which is x. And log base e, I would like for you to make sure, if you're converting, to change that to ln. ln 5 is equal to x. That is your answer. On the back side of that page, part 5. Let's look at F. We'll do F and G. So F, we have 1/2 ln 5 minus ln 3. And the directions say to simplify using laws of logarithms. When we're simplifying, that means we want it to be as small as possible. So there's a few things going on here. First, I have a coefficient of 1/2. That means this 1/2 becomes the power of the 5. And hopefully by now you know that the power of 1/2 really means square root. We also have subtraction going on between the two natural logs, which means we can condense with division. So one step at a time, I have ln 5 to the power of 1/2 minus ln 3. Then I have ln square root 5, because I know that the power of 1/2 is the same thing as square root, minding my P's and Q's. And I can condense this subtraction with division, and so I have ln of root 5 over 3, and that is simplified. G, log base 10 of pi plus 2 log base 10 r. So again, I have a coefficient over here, so that's going to become the power of r, so I'll take care of that first. Log base 10 pi plus log base 10 r squared. And I can condense addition with multiplication. So I have log base 10 of pi r squared, which is also the formula for area of a circle. That's my answer, condensed. Completely simplified. Let's look at part 6. We're going to expand. Now, to expand means to make it as big as possible. Let's look at part B. We've got log base 10 of xy divided by z. And here's what we have going on. I have some multiplication up top. That means that's going to be expanded with addition. And then I have these two things divided by z, which means that's going to be expanded with subtraction. So it's just going to be log base 10 of x plus log base 10 of y minus log base 10 of z. And that's it. Expanded this multiplication with this addition, and then this division with this subtraction. Let's look at part C. I've got log base 10 of x squared y. So first thing I'm going to do is I'm going to separate or expand this multiplication here between x squared and y with addition. So I have log base 10 of x squared plus log base 10 of y. And then utilizing my power rule, this power of 2 becomes the coefficient here of log x. So I have 2 log x plus log y. That's my answer, completely expanded. We did not do part 7. Let's move on to part 8. And let's look at part A. We've got log base 2 of x plus 2 plus log base 2, 5 is equal to 4. When we're solving equations with logarithms in it, first thing we want to do is make sure we condense those logarithms. So I have log base 2 and log base 2. I can condense this addition with multiplication. So this becomes log base 2 of 5 times x plus 2 is equal to 4. Now what I have is a problem just like on the other side of the paper, where I was evaluating a logarithm without a calculator. 2 to the power of 4 is equal to 5 times x plus 2. And then let's just solve for x. We're back in algebra 1. So 2 to the 4th, we've got 2 times 2 is 4, times 2 is 8, times 2 is 16. So this is 16 is equal to, distribute the 5, 5x plus 10, subtract 10 from each side. 6 is equal to 5x, divide by 5, and we have that x is equal to 6/5. Is my answer. Now, so any of the problems such as B, C, and D, you want to condense those logarithms on the left side of the equal sign and do those problems just like I did this one. But what happens when you have logarithms on each side? It might even be easier. Let's look at F. Log base 2 x squared plus 8 equals log base 2 x plus log base 2 6. So the first thing I'm going to do is I'm going to condense the right side. This becomes log base 2 of 6x because I can condense the addition with multiplication. Bring the left side down. Now, there's nothing else I can do as far as condensing, but this is what you need to notice. 1, I have log base 2 on the left, and I have log base 2 on the right. And if I have that, then what that tells me is what's on the inside is equal to each other as well. So all I have is a quadratic equation. X squared plus 8 is equal to 6x. So again, if you have the two logs of the same base on each side, and you just have one log on each side, then the insides are equal to each other. And so this, all we have to do here is, you should know that since you have an x squared term and you have an x term, you have to factor. So I need to set it equal to 0. So I have x squared minus 6x plus 8 equals 0. And using Mustang factoring, I need to find two numbers that add to negative 6 and multiply to positive 8. X minus 4, x minus 2. And if you do not know what I just did there, I did Mustang factoring where a is 1, b is negative 6, and c is 8. Look at my factors of a times c. We've done that all year long. Now I set each factor equal to 0 because I'm actually solving for x. Oops. I had x minus 4 equals 0 and x minus 2 equals 0. Sorry that disappeared so quick. Rewind it if you need to see something else. Here we get x equals 2 and positive 4. Let's do one more really quick that does not have factoring. Actually, D has factoring in it, and so does E. So they're all the same. D, E, and F are the same. So that's pretty much it. Make sure you can work the problems from each one of those sections on logs 1. Make sure you can work the problems from note card 56. And you should be good to go for the test.